Viewers, Assalamu alaikum. Welcome to another significant episode of our regular program, Engineering Spectacle. In this program, we break down big ideas, bold innovations, sophisticated concepts, revealing the brilliant mind behind every branch of engineering, such as electrical engineering, mechanical engineering, civil engineering, industrial engineering, computer engineering, and so on and so forth, all working together for the benefit of humanity. Also, inspiring the young heart to lead in honesty, dedication, and collaboration so that every individual will benefit for the engineering activities.
Our guest today is not any other person but Engineer Joshua Titus Sanga. Engineer Joshua Titus Sanga is not a new person to us. We know him. He has been working actually not only for people in Toro but for the entire state. Let me tell you one good thing that we consider or we observe from engineer. He supervised and monitored the work of a project for water for all the states in the nation, including FCT, but excluding Bayelsa. Don't be hurried. He will tell us why is that so. Engineer, you are welcome to the program.
Thank you very much.
Engineer, before we start, let's have a little background of yourself, because there are a lot of things that we need to discuss, but let's have a little background of yourself first.
Thank you very much, viewers. Thank you for the opportunity. As you rightly say, my name is Engineer Joshua Titus Sanga. I'm from Gumoto, local government area of Bauchi State. I'm a fellow of the Nigerian Society of Engineers, fellow of the Nigerian Institution of Civil Engineers, fellow of the Nigerian Institution of Water Engineers. I'm currently also the national chairman of the Nigerian Institution of Water Engineers.
That's great.
Yeah, I was born and bred in Gumo, as I said, to a local government area of Bauchi State. I did my primary school in Gumo Sanga Primary School.
That's great.
From there, I did government secondary school in Gumo. It was in my second year in the technical college. It's a 3-year program that most of my friends were saying, I'm going to this university, this polytechnic. So that was me, the only me that was opening a workshop in Gumo. I need to aspire also to further my education in the technical or engineering field. So I met the guardian counselor who advised me to ask me what I want to study. I said civil engineering. I said I should have studied building technology, not carpentry.
I see.
So I say it's not too late. I will study the building technology and the carpentry and write both in my final exams.
That's interesting.
They agreed. So I started attending building technology and also carpentry classes. And I wrote the 2 papers. And I also passed the 2 papers. So with that helped me to go to Kaduna Polytechnic to study diploma in civil engineering. So from Kaduna Polytechnic, it was while I was there, I now fully understand civil engineering has 3 fields. You can specialize in highway, you can specialize in water resources, you can also specialize in structural engineering. Because I come from a village where there is no water, we 3 kilometers to go and fetch water and come back. But dry season was hectic. I said, I will better specialize in water so that I can help my community when I graduated, when I have the opportunity. So that made me to like water resources engineering. And I knew there was National Water Resources Institute in Mando, Kaduna. So I did not go back to Kaduna Polytechnic for my check. Instead, I went to National Water Resources Institute, Kaduna, so that I was specialized in the area of water resources. Spent my 2 years here at National Diploma. I graduated successfully, and I was sponsored to Anambra State Water Corporation. OCA, that's why I did yes, that's why I did my NYSC in the Water Corporation. So that's why I began to have my practical, on-hand experience of water resources. Although in Mando we go for small practicals, so that was 1 year.
1 year
practical experience during my NYSC.
That's good.
For completion of my NYSC, came back, attached myself to some water engineers. That I went to Abu National Water Resources Federal Ministry of Water Resources in Abuja, asked for any good water specialist. And they now attached me to one engineer, Sanga.
Okay.
And I went and begged him that I want to understudy. I don't need any payment, but I will follow him to field so that I will have increase more knowledge in the water resources. He allowed me and taught me a lot of aspects of water resources, from geophysical survey, to borehole construction, to estate water supply, mini water treatment plants, tank design and construction, a lot of water resources aspects. So from there, I got a job from Federal Ministry of Housing, Works and Housing.
Okay.
So in the Federal Ministry of Works and Housing, there is water and sanitation department. So that when government build houses or any federal government-owned institution like Federal Secretariat, barracks, federal medical centers, universities that are owned by federal government, that division of water and sanitation division supply water to such institutions. That's great. So that's why I work with the federal government. But sincerely speaking, when I started working, I made up my mind that I will not just be a civil servant. I want to broaden my mind. So I set a target of 15 years to garner experience before I start my own engineering venture. That's good. So thank God after some 16 years or so. So in between, I went to UK to study my master's in civil engineering management. So, but all my research work in the UK University of Wolverhampton was in water resources. So I also have broader experience because cutting across different countries,
Exactly.
and, different continents, we have students. So we share experiences of water supply across nations, countries, and knowledge.
Sharing knowledge from people that comes from different countries,
Different
areas.
Different water challenges.
Exactly.
Even the UK water supply system, we all study it. So at the end of it, I came back. When I came back after 16 years, I resigned from the Federal Ministry of Works, Housing, voluntarily, and opened my consultancy office in Abuja for water resources, in particular, but civil engineering in general. Because civil engineering comes, because I told you civil engineering is 3 phases.
Exactly.
So when you study, you have a broad knowledge of all. So after about a year or two, that is when my state invited me to give me an appointment as the Director General, which is the Public Procurement Bureau. So His Excellency Governor Abdulkadir Mohammed gave me that offer because I follow my state, I heed the call of my people, I can be there for the last 7 years. So that's just a summary of.
What a beautiful biography. The record I have with me that tag Sanga at 53. I made to understand that you supervise and monitor work for all the states in the nation, including FCT, but excluding Bayelsa. Engineer, maybe you may enlighten the public. What is it that Bayelsa is excluded? After all, it's the only state that remain not supervised in your work.
Thank you. In my biography, I must add that I am married to Blessing.
Great.
And we have 5 children.
Exactly.
So that my family will not say I've forgotten about
Yeah,
that.
really.
Thank you very much. During my work, both in government and private life, I've designed a lot of water infrastructure. I have supervised a lot of water projects. I work with the MDGs, the Millennium Development Goals that time. The French Urban Development. An able asset engineer, Mohamed Babakobi. So during these years, travel across the country to supervise water project in Millennium Development Goals. And even after I left service, a lot of people give me contracts, give me consultancy to supervise, design whatsoever. So that's why every state in Nigeria, as you rightly said, is Bayelsa. Bayelsa maybe somebody did not give me a work there. That's why I did not go.
I understand.
That's why I did not go. But Bayelsa said also, it's very easy to get water, especially groundwater.
Yes.
You don't need heavy equipment, you don't need much research. You just
the
water table is high, so they don't have much challenge in water. So maybe that's why they don't focus more on water. They may focus on other areas of need. But as you rightly say, every state in Nigeria, I know I have either a design, a submission, or a construction of a water facility that I have done. In the Northeast, maybe I can even count some local governments. Almost half of the local governments have one there. So definitely it's a worth experience, and I drive joy in doing it. When you see a community that doesn't have water and you see the kind of joy the people will have, and it gives me a lot of happiness. And that's what even brought me to Toro, as you rightly say, not only Toro. I do community service, repair works, provision of water supply, free of charge to my community. Because of the joy that people have when you just break the rock and water start washing up, everybody will shout. The community will be happy. So definitely that is water.
That's interesting. In some other profession, like electrical, sometimes you will find out that some of the cables that are being used are substandard. So when drilling a borehole, for instance, we understand that you place pipes, you give it more priority. Maybe there are some different types of pipes that you are using there. I want to know, is there any problem that the electrical people used to have, that is pipe that are substandard? And if such thing happen, what actually will be the result of the finishing of the entire project?
Thank you. In engineering in general, there are different quality of every material. Almost every material have standard and substandard.
Exactly.
Sometimes it depends on the financial availability. If, let's say, you want to build a house, somebody with 20 million, you cannot even finish 2-bedroom flats because you say it's too small. But somebody with 2 million, you will build a 2-bedroom flat and still stay there. That depends on the materials, the quality of materials. Exactly. So engineering in general, and water resources, not only pipes, in everything, engineering, there are qualitative materials and there are substandard materials. There are, even in pipes, they have different bars, 10 bar, 8 bars, and that's the pressure that the pipe can withstand. So depending on the money available for the client, you design. Sometimes, well, especially like me, I make sure I clearly tell you what I'm giving you. When you give me this money, this is what you have. When you don't have the money, you say this is what there are money available, I'll tell you. You can't get that, you will get this. But in pipe, in cables, every aspect, especially in pumps, that's why even the problem comes. There is SQ Flex pump that even 1 horsepower will go for 300,000. But there are some pumps that will go for 38,000. So you can see, the one for over 300,000. If there is any fluctuation in light, even if the switch will go up by itself and your pump itself is safe. Exactly. But if you go for the 38,000 cheap one, whenever there is a fluctuation, you should just burn the pump. There is no any protection. So that's how it is. Even in pipes, there are different pressure pipe, there are different design of pipe, and different methods of pipes. So it depends on the money in general. So, but ideally, as an engineer, you design for the best. Exactly. You design for the best. But when the client says he cannot afford, there are alternatives. But still, even in the cheaper ones, you still maintain some quality.
We are giving more priority to borehole because these are the water system most of the villages are using.
Yes.
For instance, now there are some safety that you consider during drilling borehole. Apart of the standard or substandard of the pipe, you find out that a place where maybe, let's say, an abattoir or a graveyard, or where waste are being dumped, or public conveniences are there, does that make an impact in drilling a borehole in such kind of area?
There is water quality, groundwater quality, since we say we should limit ourselves to groundwater, that's boreholes. Groundwater generally is mostly pure and good, especially in the northern and middle belt of Nigeria. Most of the places, basement areas, groundwater quality is always very, very good. Sometimes, let me tell you, sometimes even the groundwater you get in basement formations are quite better than even the treated water you have in your tanks, water boards or municipal water supplies, because of the quality. Because you say filtration, it already go through filtration through the rock because there are different layers. Before it comes to your borehole, it goes through formation, cell formation, different filtrations. So the one that will come there will be very good quality water. So, but as you say, there are things, impurities that can find their way into the boreholes. As you rightly say, maybe there is maybe a borehole or septic tank or any waste dump or abattoir or anything, as you say, definitely it will affect water quality, especially if the proximity is very close. Ideally, we recommend it is about 3 to 5 meters interval. If it is a basement formation, that is rock formation, you have to give a 3 to 5 meter interval before you dig your bore. And the funny thing is that, especially in urban areas, houses are close to each other. So when somebody build a house, if I come to build my own, I will just look for one place and dig. No, you don't go to check whether your next neighbor sewer is just across the fence. Maybe just it's when see soccer here, and you came and drill the ball. That's not good. It will definitely make the ball impure. So the best is for you to know where that person's waste is. Then you now decide your own borehole far.
At least it has to take some meters away.
Yes, minimum of 3 meters away.
Minimum of 3 meters.
3 meters away, so that there will be level of filtration and the water, there will not be interference. But if possible, go as far as, if there is space, go as far as possible from that waste. Another source of impurities also is in the finishing of the borehole, the wellhead. Sometimes the wellhead of the borehole is low. So therefore, if there is any water flood or any surface water, dirty surface water that comes, it will just enter inside. And so that's why it's good to raise the water head up. So that even if there are flooding, it will not cover. Even if there are wastewater or any other thing, or as you say, maybe abattoir water or anything, it will not get into the borehole. Definitely there are safety measures we must take to ensure that water, boreholes water are good.
That's quite interesting. If I think the question I intend to ask, but you have already given us the answer. And there is some way that I don't know whether you have some measure to take in terms of drilling a borehole in a space. How did you get to know that this is the right position for drilling a borehole, and then the level of water in that will consider the depth to which the borehole?
Thank you for that very important question. Even before you drill the borehole, ideally you go for geophysical survey. Mostly is the resistivity method that we carry out in Nigeria. And in Nigeria there are different formations, as I said. There are basement complex, there are sedimentary formations. So in the basement complex area, that is middle belt to part of the north, not far north. If you go to Maiduguri area, or you go to Delta or the southern area, is sedimentary. Some part of Lagos is sedimentary. So those survey methods may vary. But definitely what you do is to carry your parameter, the survey equipment, you go, you see people holding cable, drawing it, and even hitting iron on the ground in order to discover. What they are doing is to send current into the rock, if it is a rock formation. It is sedimentary, is also through the sedimentary formation. When you send that current, the current in different intervals, maybe 1 meter, then 3, 5 meters, then 10 meters, 10 meter interval, or Depends on how the spacing you are doing.
Yeah.
So when you send the current, you take the parameter, take the measure of resistivity.
I see.
That is the resistance of current passing through that formation. So if you send the current through the rock, and the resistivity, the resistance of that current to penetrate that formation is high, that means if you do 1, 2 up to like 50, like in the basement area, highest maybe around 100, 120 meters, you get, you are looking for fractures in the rock. Because after the soil surface, what you get is a rock. Almost the whole of middle and the rest, when you go down, you meet a rock. So what you are sending is to send the current inside those rock formation and take the resistivity. So at different intervals. When you take the resistivity at different intervals, maybe at 20, 30 meters, the resistivity is maybe 900 ohms, 800. You keep going. Maybe you find wire maybe at 45, 50. It's now 300. So you have seen that the resistivity has dropped down to 300 from about 800. So you know that at that level of depth, 40, 45 meters, the resistivity is low. That means the rock is fractured. That means there is a crack in that rock. And we all know if there is a crack, water should flow inside the crack. So what we are measuring is actually cracks in those rocks. If you send the current and there is no it's high all through, you know that there is no fracture, there is no crack in that rock. So the possibility of water passing through that crack is not possible. Then you go to another place and survey. So that's what we measure. So when the resistivity is low at some level, that's what determines the depth. Maybe the resistivity, you will not find it at 45, 50, maybe you find it at about 100. Yes, that's why you leave your borehole now at 120 or 110 meters. So that water that you see, that fracture water you got, will be stored down and you put your pump there to it. So that's what determines the location and also the depth. Sending current through your survey equipment, through the rock formation or the soil formation, taking the resistivity measurement, and if you discover low resistivity, it shows there is water. If you discover high resistivity, means there is no water. And the depth you discover the low resistivity is the depth you are to terminate your bore. So that's just the mystery about it.
There are some saying that maybe the layman's understanding that when a borehole is being drilled and there are a lot of rocks that have been discovered, the water that will be obtained will be sweeter than the one that doesn't have rock. I don't know whether it's true.
I don't think, generally speaking, I can't say it's sweeter. I don't know. But it all depends on the mineral resources in that soil in that area. You know, there are, as I say, different soils have different soil properties. So let's assume you go to Niger Delta area where they drill oil. You see, you'll be careful not to get oil there, oily water there. You'll be careful not to get salt water there. Only in part of Lagos there are salt water. So definitely, you know, that will determine the taste of the water. So, but ideally, everybody knows if you get good rock water, the water should be clean because of the filtration process. As layman will say, it will be sweet. And the best part of it is that that kind of water may not even dry. If you get water from the rock, however you pump it for 1 year, that water, if you get good water, it will not dry because as you are pumping it.
That's precisely what I intend to ask you. Yes. Sometimes when a borehole has been drilled, you will realize that water is coming very low. So maybe is it the location or the depth that that borehole is being drilled is concerned about the lower pressure of the water?
There can be low yield in borehole. That's why I said basement water from the rock is almost low yield. And there are some that are much, but still there are some that are low. It depends on the water that is there. Even if you go 300 meters, if there is no fracture, good fracture, in that cell you will never get water.
That's interesting.
Sometimes even it's because you may get small water, maybe around 70, 80 meters. If you say, okay, let me just continue that. The water you get around 70 meters, you will get a cell formation at 100 meters that doesn't have water. So it will swallow the water that you have gotten between 70 to 80 meters. So the best is the little water you have, you now design the pump you have to use. If the water is much, you use higher capacity pump. If the water is low, you use lower capacity pump. So that the water will be pumping gradually as it is recharging. So it's not how deep you go that you get water. It depends on the water availability.
That's quite interesting. Yes. Well, viewers, we have been discussing with engineer Joshua Tatu Sanga. He has enlightened us about the issue of water of different capacity, of different ways. Before we round up the program, I would like to ask engineer, what are some of the challenges that you have ever encountered? Maybe in the issue of boreholes or in the issue of dams that you have been using to supply water for the public.
Thank you. Personally, let me broaden it. Most of the challenge we water engineers or the society get for lack of water is political will. That is the major challenge. Where there is a will, there is a way. A lot of people focus government from local government to state to federal. You see them focusing on roads, on buildings, on big infrastructure, but no water. So the major challenge we water engineers face is political will. That people, the government at all levels, local government to federal, will commit enough resources into water supply. You see one road, 10, 20 billion. One road, maybe let's say in federal ministerial works, even now they are giving 500 billion. So, but the budget of the whole Ministry of Water Resources may not, the whole Ministry of Water Resources may not be more than 100 billion or 200 billion. But one road is carrying almost $1 trillion there. So you can see the difference. So if we are to get water at the national, at the state, at the local level, government level, all we need is for our political people, for the head of governments to give more attention to the water supply. And for us, even those developing estates, you see them concentrating on road and power. They don't even provide water. They leave every person to attend to everybody to go and look for water by himself. It's not to be so. The way the estate developer will provide electricity and road, you should go ahead also and provide a centralized water system. That will be cheaper to all the residents of such an environment.
You see the issue of each and every house drilling.
Then yes, if you do that. Even if it's a community, if every borehole now, I don't think you can drill a borehole in Bauchi in less than 1 million naira with a pump. So if 100 houses, that's 100 million. But if they will join and do it, maybe with 30 million centralized system, everybody with 30 million, everybody will get. So that coordination needs to be developed from the community to the local government to the state and everywhere, so that we'll have a universal water supply system to communities. Doing that also will reduce diseases, because most of the diseases we face are waterborne diseases, and that will reduce the number of people trooping to our hospitals. The health system will also be less. So that is my
viewers. I know engineers have a lot to say, but we must stop here because of the time factor. Nevertheless, he have enlightened us on what to do and the cheapest way of having water instead of having each and every house drilling borehole on water. We are going to stop here. Perhaps if we have the time or the engineer have the time, we may come and discuss about other things. For me, it's goodbye. Engineer, thank you very much for having your attention to us.
Thank you, viewers. Thank you, DATV.
Viewers, Assalamu alaikum. Welcome to another significant episode of our regular program, Engineering Spectacle. In this program, we break down big ideas, bold innovations, sophisticated